Okay, so this is my video number 32. So in this video I'll give you example of how to use the convolution, the Laplace transform of the convolution. So for this example, let's consider this example. I want to evaluate. Let's say we want to find the inverse of this function, u squared plus 1. We want to find that. Alright, bear in mind that I think it's not difficult for you if you have fx equal to x. Yeah, so the Laplace transform of fx u, I can write this as fu. This is just it's not difficult for you to find out this thing. Integrate from 0 to infinity. So we have e minus ux fx is x dx. So you can evaluate this. That will give you 1 over u squared. Okay, and if you want to evaluate, let's say, sine of x u, that give you, let's say, gu. This is integrate 0 to infinity e minus ux sine x dx. That will give you 1 over u squared plus 1. Okay, so just use integration by parts, and as well as there. And also we have the inverse of the Laplace transform of fu and gu. This will give you the convolution of f and g, which is defined as 0 to x f t minus some variable tau g tau d tau. Okay, so we're going to use that in order to solve to calculate the inverse of that function, 1 over u squared plus 1. Okay, so using this, all right, so I can write this equation. I mean, I can write that expression in that. So becomes 1 over p u squared plus 1. This is just inverse of 1 over u squared plus 1. Okay, so you can easily recognize this. You can easily recognize this is the Fourier transform, let's say, for u, for this, all right, and this is, let's say, g of u, where you have this the Fourier transform of this will give you the 1 over u, that you have x, and u squared plus 1 that give you sine. Okay, so if you apply this, so we have inverse those things, fu and gu, so that we have, this is just integral from 0 to infinity, because we apply the convolution directly, because this will give you fx gx, and by definition is that. So we have 0 to x ft, our f is x, so we have x minus tau and sine tau d tau. Okay, so again you can integration by parts here. That will give you x minus sine x. Okay, then in order to find the solution of this, well, I think we just need to find the inverse of that. So this is the solution of what we want to find here. That. Okay, now let's say if I want to evaluate the equation of the form what we call integral equation. Fx is equal to yx plus integrate 0 to x kernel x minus t y of t dt. Okay, so in this case y is unknown. Yeah, y is unknown. So if you want to solve for y, so we need some trick how to do that. So if you look at this inside here, I mean the on the right hand side that involve integral, you can see this is the convolution of two functions. Yeah, the convolution of two functions. So if you take the Laplace transform both sides, left and right, yeah, take the Laplace transform, both sides. So we have L of f, this is equal to L of y, and that we have the Laplace transform of the function k and Laplace transform of function y. Yeah, because this is the definition of convolution of between two functions. So we have that. So we have that one. And then you can solve for y. You have Ly is equal to Lf divided by 1 plus Lk. So that gives you the solution for that. Then you can find the Laplace transform of y, Laplace transform of all those things. Then you can solve the problem. So let's see example. Next example. Let's say I want to solve yx equal to x cubed plus 0 to x sine x minus t yt dt. Okay, again this is the convolution of two functions. So you can recognize this thing. Right, so if you take the Laplace transform, so what we have is the Laplace transform of y equal to Laplace transform of x cubed, and for this is the convolution of Laplace transform of sine and Laplace transform of y. So we have plus Laplace transform of sine x convolution with Laplace transform of y. Then we solve for what for Ly. So solve for Ly, that will give you L x cubed over 1 minus L sine x. Okay, and it is not difficult. You can find the Laplace transform of x cubed, which is 3 factorial over u to 4 over, and the Laplace transform of sine x I've given earlier, so this one is 1 over u squared plus 1. Okay. You can simplify this. That will give you 3 factorial over u4 plus 3 factorial over u6. And then to find y, to find y of x, we apply the inverse Fourier transform, inverse Laplace transform. And again, this is I don't think it's difficult for you to find the Laplace transform. Then with the inverse Laplace transform, you can have yx is equal to x cubed plus x5 over 20. So that's the result. Okay, so I think that's enough. I give 2 examples for this. I stop here. Thank you.